All right, as promised, here is our Quiz 8 review session, starting with number 3 at the back of Chapter 13. That's page 352 in your textbook. We're going to take this problem and then do several additional kind of supplemental problems that follow up with it, which will cover all the types of problems that you have on the quiz tomorrow. So I copied the entire problem here so we'd have it all in front of us. Kate's Catering provides catered meals, and the catered meals industry is perfectly competitive. Kate's machinery costs $100 per day. That tells you the fixed cost. Her variable cost consists of wages paid to cooks and the food ingredients, and down here below it gives you the table of variable costs. So the questions begin: calculate the total cost, the average variable cost, the average total cost, and the marginal cost for each quantity of output. This is all review from last week or maybe even a couple weeks ago, and hopefully this kind of stuff comes pretty easily by now. Total cost of 0 units of output is not 0 because remember our fixed cost is $100 per day, so total cost of 0 units is still 100, and then we're just going to add our fixed cost of $100 to each of these variable costs to get our total costs. Then our average variable cost, average total costs. I've done these calculations prior to coming in. I'm not just doing these in my head, but just to kind of lay them out for you. Remember, average variable cost is variable cost divided by quantity. So for this first one, at 10 meals, our variable cost is 200. 200 divided by 10 gives us 20. And then it goes on like this: 20, 15, 16, 17.5, and 20. And our average total costs, again, no average total cost for the 0 units. Average total cost is equal to total cost divided by the quantity. So 300 divided by 10, 30, and then it goes 20, 19.33, 20, and 22. Then our marginal cost. Marginal cost, remember, is the change in total cost divided by the change in quantity of output. And here we do have to deal with that denominator, the change in quantity of output, because the quantity changes by 10 each time, not just by 1. So for the first 10 units, we add $200 in total cost. That's the change in total cost. Change in total cost here, 200. Change in quantity is 10. 200 divided by 10 is 20. Then change in total cost of 100 divided by another 10. So it goes 20, 10. Change of 180 divided by 10 is 18. Change of 220 divided by 10 is 22. And change of 300 divided by 10 is 30. So there's our marginal cost. Again, that's all stuff that you would have been doing on the quiz last week. Now we use that to start answering our questions about a perfectly competitive firm. Now to B, what is the break-even price? So remember that we are looking for the minimum average total cost for the break-even price. So we just scan down the average total cost column for the lowest one, and it's 19.33. So the break-even price is 19.33. And the shutdown price is scanning down the average variable cost column, the lowest one of those, which is 15. So the shutdown price is $15. Next, suppose the price at which Kate can sell catered meals is $21 per meal. In the short run, will Kate earn a profit, and should she produce or shut down? So starting off with, if it's $21 per meal, we are looking for the last unit where the marginal cost, where the marginal revenue of $21 is greater than the marginal cost and that is, start going down one by one, it's here. They wouldn't produce the 40 units because 30 is the last time where marginal revenue is greater than marginal cost. So in the short run, will Kate earn a profit? Then we need to figure out, for profit, total revenue minus total cost equals, total revenue is price times quantity. Price is 21 times a quantity of 30 minus total cost of 580. 21 times 30 is 620 minus 580 gives us a total profit of $40. So if we've got a price of $21 per meal, our profit maximizing quantity is 30 and our profit is $40. Whenever you have a positive profit, it should certainly produce. So there's our answer. Next, I'm going to go back and erase some of what we just did. Use some new numbers. If our marginal revenue is $17 per meal, the price is 17, or price is equal to marginal revenue in perfect competition, then we stop earlier. We stop here at 20 units. So quantity is 20. And our profit or loss is going to be total revenue is 17 times 20 minus total cost of 400. 17 times 20 is 340. So negative $60. You could say our profit is negative $60 or our loss is negative $60. Either way I would count it right. In the short run, should she produce or shut down? So two different ways we can figure this out. One is that our loss of $60 is less than our fixed cost of $100 per day. If we shut down, we lose that fixed cost. We lose $100 per day. So that tells us that she should produce. And the other way we can figure that out is that we can take this shutdown price of $15 and just say, okay, is the price greater than that? Yes, the price is $17. So in the short run, both of those ways of looking at it tell you that she should continue to produce in the short run, even though she's losing $60. She's still better off. Alright, and our last part for this problem, what if the price is $13? You can probably guess right now what the outcome is going to be, but let's go through it anyway. 13. Again, we're going with a 20 as our best quantity. Same as before, which might seem like it can't be right, but that's still the best situation here. Well, it's the best situation if they were going to produce. So let's see the outcome of that. Their profit total revenue of $20, or sorry, 20 units times $13 minus the total cost of $400. 13 times 20 is $260. Again, minus 400 equals negative $140. So their loss is negative 140. And in the short run, again, are two different ways of telling this. She could lose 140 by producing or lose 100 by shutting down, so she will shut down. Alternatively, we can look at this price 13, compare it to the shutdown price 15, and say the price is below the shutdown price, so she should shut down. So there we are. That is number 3 in the back of chapter 1. That's a good problem to summarize a lot of what we've done the last couple days. Now we've done a couple other things, and let's bring those into the picture with this same problem down below. First, do you think that it is likely or unlikely that a real-life market for catered meals would actually be perfectly competitive? Explain. What I'm looking for here is that you are able to recall and recognize and apply the elements of a perfectly competitive industry, which mean that those include the fact that firms are a small part of the market, that they are therefore price takers. Their pricing doesn't really affect anybody else's, and they should take the market price. They can't even hope to produce enough to affect the market price. That you have identical products, also known as undifferentiated, use that term in the video, and that there's easy entry and exit. So if you get a question like this about do you think this kind of industry is likely perfectly competitive, it's one of these where you know, depending on how you argue it, you could probably come up with different answers, and I'd give you full credit. What I'm looking for is you're able to apply these concepts. So is it likely that a catering business is a small part of a larger market? And it's arguable, but probably not. You know, even in a decent sized city, there are you know, anywhere from a half dozen to a dozen major catering options that people have, but that's not enough to be a perfectly competitive market. Perfectly competitive market, we're talking about hundreds or thousands of producers. So a small part of the market, not really. Each firm is probably a big enough part of the market to affect the overall market, probably. That's very arguable. Let's skip down to number 3. Are they identical products? Definitely not. Catering is highly differentiated. You know, people like one cook's food over another. Certainly, there's no way to make catering, I don't think, perfectly identical. So for that reason, they're probably not price takers either. Easy entry and exit, yes, it's probably pretty easy. It's not a huge capital cost. Again, these kinds of things are arguable, and it's not like I'm asking you to have a detailed knowledge of the catering business to be able to answer these things. You can use common sense and be able to apply these concepts to the answer. So in answering that question, I would say most likely not, mainly because their products are not identical, and for catering companies, they're probably not a small enough part of the market. Each one can probably affect the market price a little bit. They can undercut each other. One could price above the other because their products are better, and so on. All right, number 2 moves us back into some of the numbers analysis. Complete the table below and graph the firm's supply curve. What's the relationship between the supply curve and the marginal cost curve? So we can just go back to the table of marginal costs that we found before. If the market price is $10, our marginal revenue is $10, the firm would, well, actually we should stop here and say $10 is less than the shutdown point. So the firm would supply 0 in the short run. If the market price were $10, they would shut down. If the market price were $18, that matches this marginal cost here at a quantity of 30, so they would produce 30. If the market price were $22, again, that matches a marginal cost number, quantity of 40. If the market price were $30, that goes along with 50. So to graph the firm's supply curve, we just put quantity and price, and we have 4 points. Supply 0 quantity if the price is $10. If the price is $18, supply 30. If the price is $22, we'll supply 40. And if the price is $30, we'll supply 50. The graph doesn't have to be exactly perfect or to scale. There's your supply curve. And then the second part of the question, what is the relationship between the supply curve and the marginal cost curve? That's just a concept that you should know. The supply curve is the same as the marginal cost curve. Usually the way it's worded is that the firm's marginal cost curve is its supply curve, or vice versa. Its supply curve is its marginal cost curve as long as you're above the shutdown price. So it's one other thing we know about the supply curve that I didn't draw on there, but it's a good idea to do this, is that we know that it ends, the point where it hits 0 is at the shutdown price of 15. Anything below 15, basically, you can think of it as ending or starting at that shutdown price of 15. Alright, that's 2. One more. Using the situation in part C, where the market price is $21 per meal, sketch a graph of the firm's situation which labels MR, MC, ATC, profit maximizing quantity, market price, and area of profit or loss. Whew, sounds like a lot. So here we go. Remember when I said to draw one of these perfectly competitive graphs, you're going to always start the same way. Our axes are quantity and price. Start with the horizontal marginal revenue curve wherever you want it. It's even better to go MR equals AR equals P to remind yourself of that. And then draw the marginal cost curve, again, anywhere you want. Find the intersection of those. Drop the dotted line down to the x-axis and call that Q star for the profit maximizing quantity. And then label over here P or P star, I just usually use P, for the market price. Since I asked a market price in the question, I'll just go market price. And then we don't have ATC or the area of profit or loss, so we'll add that. And here's the part that varies depending on whether we're profitable or not. At $21, we said that we will produce 30 units and our profit would be $40. So we could say that this quantity equals 30, this market price is $21, and our ATC, we don't need to draw exactly where it would be or to scale. We just know that our ATC is going to drop below the market price. Remember, when price is greater than average total cost, that's when we're profitable. So pick any point below the MR equals MC point on the MC curve and draw ATC through that, where that is the minimum ATC. It doesn't need to be perfect, just looking for that to be in the right spot and for that to be about looking like the minimum. Then the area of profit, do that in another color so you can see that clearly. Red. Start from MR equals MC, drop a line down to ATC, and then over to the y-axis. And that is our area of profit. That's it. So, hope this was helpful. Once again, I should be available on the periods 1 or 2 or the PRT between 1 and 2 if you want to stop by tomorrow morning to go over any of this. Good luck. I'll see you period 3 tomorrow.